a group of students from Harmony Science Academy, Pflugerville, and our project is on rotational inertia and how different diameters of wheels affect the velocity of a car. When the moment of inertia is greater, the object has more tendency to stay at rest, so it takes more force to cause it to accelerate. So since a car with a larger diameter has a larger moment of inertia, we hypothesize that this means a car with a larger diameter will move slower. When the diameter of a wheel is increased, the axle weight increases with it. This causes the increase of inertia and the loss of acceleration. This relationship can be seen in multiple formulas, such as the radial acceleration equals linear speed squared over radius formula, as well as the inertia equals mass times radius squared formula. This leads to the smaller rates of change in velocity, leading us to hypothesize that the larger the diameter of a wheel, the slower the velocity of the car will be. We were thinking about what we were learning in physics on the topic of rotational inertia and decided that it would be interesting to test the impact of inertia on a car's performance. I and my various teammates are interested in STEM fields and were mesmerized to discover the importance of small details in the performance of race cars. We thought that this experience would allow us to gain more insight into what goes into mechanical engineering and the applications of physics in design. We began with this idea and then started our background research to better inform our hypothesis and our problem statement. And then we further developed our MyPBL page with our needed materials and methods, and then carried out our experiment. We then edited together our footage from our experiment and uploaded it to our website. And then we finished the social studies and our ELA components of our site, and finally worked on the research paper and then the brochure. Historically, when engineering racing cars, every little detail of the car's design impacts its functionality, and the wheels are no different. From the diameter of the wheels to the center of the car's mass, every detail is very important in getting the car to function in the way that you want it to. Galileo, Euler, and Newton all had ideas that developed what we know today as inertia, and all of these play a factor into how we design cars today to best minimize the effects of rotational inertia, to maximize speeds in some cases, and in other cases to maybe add a little bit more inertia so that it is easier to stop a car in hopes of diminishing crash fatalities. Thank you for watching Harmony Science Academy Pflugerville.